today we start our unit on quadratics. Okay? Remind me, please, what shape does a quadratic function make? A U, also called in the mathematical language a parabola. Okay? What is the parent function of a quadratic? What's the equation for the parent function? Close. I'm being more picky. I'm sorry. What's the, no. Y equals x squared. Okay, this is one way we could write it. And the other way I heard was f of x equals x squared. Right? What's the difference in these two? This one's an equation. This one's a function. Right? This one is in function notation, so they're telling you right off the bat it is a function, so you don't have to question or worry. Okay? Not that we would worry whether it was a function or not, but you know what I'm saying, right? Okay? So, first thing we need to do in this unit on quadratics is remember our transformation rules. Remember when we talked about transformations at the beginning of this year? And I told you we're going to come back to it every time we get to a new unit? It's a new unit. So here's the general form. What does the A cause to happen? So what's that called? A stretch or compression. What kind of stretch or compression? Vertical. This causes a vertical stretch or compression. Guys, what other kind of change can A cause? What happens if A is negative? It is a vertical change. You're showing me the right thing with your hands. What is it? Yeah, it's a reflection. Reflection over what? Causes a reflection over the x-axis. Okay? What kind of change does B cause? Is there another kind of change that B can cause? So if B is negative, it would be a reflection over the y-axis. Good? Everybody okay so far? Okay. Remember that this sometimes is opposite of what we think?
Yes, because on the inside.
It's on the inside, right? Okay. What about H? So what kind of shift? Horizontal. What directions? Left and right. But that's also opposite of what we think. And then what about K? What directions? So let me ask you a question that I've been asked before, and I want to see how you respond. Is that okay? What does that do? It's part of my parent function, so that's what it gives it its original shape, right? It gives it its shape. That's how you know what parent function it is. because the squared is there. You know it's x squared. You know it's a quadratic. You know it's going to make a parabola, right? You okay with that? Any questions about that? Okay. Wait, was any of that new? Oh, no, not at all, right? In fact, you've seen it. This is the third time now. Because you saw it in Algebra 1, and then we saw it at the beginning of this year, and now we're seeing it again. So we should be getting pretty good at it by now, right? Okay. If this is my axis right here, my x and y axis, let's label x here, y here. And then this is my parabola. First of all, is this a parent function parabola? How do you know? It doesn't hit the origin, right? I know my parent function starts at the origin and goes up each way, right? So I'm just talking about in general, a general parabola. What's that point that I just drew right there? Close. Kind of rhymes with that. It is. We'll talk about minimum and maximum here in just a second. Kind of. It's the vertex. Okay? It's called the vertex. That's a nice point to know because isn't that the point we mostly look at and pay attention to when we're shifting it all around? It is, right? Okay? Well, there's another thing that I need you to know, and it goes right here. Oh my gosh, that's good. It's either called an axis of symmetry or a line of symmetry. Okay so far? Now, I didn't really do a very good job of making it parallel to the axis, but can you use your imagination that it is? Okay, it's a perfectly vertical line. So how do we talk about a vertex? The vertex is a point, right? So it's going to be, let's just say HK. Okay? Why would I say it's HK? Well, if I shift it left or right and I shift it up or down, wouldn't that be where it was? Okay. Well, how do I talk about the axis of symmetry? What is it, first of all? It's a line, right? So, how do I name it? How do we name any vertical line? I say what axis it crosses and where, right? Well, what axis is a vertical line going to cross? The x-axis. And in this case, if I called the vertex HK, where is it crossing? X equals h. So if I ask for the equation of the axis of symmetry or the equation of the line of symmetry, can you say 7? No. It's got to be x equals 7, right? It's a line. We name lines by the axis it crosses and where? Well, vertical and horizontal lines, right? But this is a vertical line. Now, will our axis of symmetry ever be y equals something? Yes, if the parabola is open to the left or right, right? We're not there yet, though. Okay, we're not there yet, so we're only talking about vertical parabolas right now, those that open up or down. But our vertex is HK and our axis of symmetry is x equals h. Are you okay with that? Okay. I'm going to write something right here in the middle of the page, and I'm going to be writing notes above it and below it, just so you know. Okay? So if you're copying what I'm writing, then just know that I need to leave some space up here for me to write some more stuff. These are two forms that we will be working with when we're talking about quadratics. I need you to know the name of each of these forms. Do you? You should know the top one, right? We dealt with the top one when we were dealing with factoring, didn't we? Find AC and then B. This was called standard form. I tried to write my F too soon. Sorry about that. Standerf. What's this one called? It's okay if you don't know. I'll tell you. Vertex form. So let's start talking about vertex form. Okay? There's two things I need you to be able to identify in vertex form. The first one is the vertex. Now, it seems like if it's called vertex form, that the vertex should be easy to spot. Is it? H, K. Is it easy to spot? There and there. That's your vertex. The other thing I need you to be able to spot is your axis of symmetry. Well, H. Is H my axis of symmetry? Oh, X equals H. Very good. Hard or easy? Easy. The next one looks hard. Does that mean it is? No. Okay, it's just a messy way that I have to write it at first, so please just trust me on this one. Okay? In standard form, I also need you to be able to find the vertex. Here's how we find the vertex in standard form. It's a point still, right? The x-coordinate of the point is negative b over 2a. The y-coordinate of the vertex is the value of the function at negative b over 2a. Doesn't that look messy? It's not. I'll show you in a second that it's not, so you can believe me. Okay? But I also need you to be able to find the axis of symmetry. Could you find that, you think? How'd you find it down here? So x equals negative b over 2a? Yeah. Isn't that how we found it here? Doesn't it, look right here, look at the graph I drew for you earlier. Doesn't it pass through, like if this was 3, this would be 3, 2. Doesn't this line pass through the x-coordinate of the vertex? Do you see now why we have the axis of symmetry being the x-coordinate of the vertex? We're even saying x equals h. Doesn't x equal h right here? We're saying x equals negative b over 2a. Doesn't x equal negative b over 2a in the vertex? Yeah. Now, this looks way messier than this. It's really not. Can I show you some examples of what I mean? Okay. So, in your homework, you're going to be asked to do several different things. There's several different sections in your homework. Okay? But it's going to give you a problem like this. F of x equals 2 times x minus 2 squared plus 5. And the directions are going to say graph, identify the vertex, and axis of symmetry. Okay? So you've written the problem, because we write the problem on our homework, right? We need to find the vertex, and we need to find the axis of symmetry. Those two things seem pretty simple because it's in vertex form, right? What is the vertex of this problem? So why is it 2, 5 and not negative 2, 5?
Because when it's in the parentheses, it's always opposite. If it was positive, if it was plus 2, then it would be negative.
Right, because the formula is x minus h. So if it says x minus 2, the value of h is 2, right? Okay. What's the axis of symmetry in this problem? X equals 2. You guys have that down pretty well, right? Here's what I want from you when it says graph. Okay? I don't want you getting graph paper. That's not what it's asking for. That's not what that's not what it's time for, really. Okay? I want you coming over here to the side, and I want you to graph something that has a vertex of 2, 5. So that's the vertex. 2, 5. We label the vertex. Does this parabola open up or down? How do you know it opens up?
Because it's positive.
So if A is positive, it opens up. And if A is negative, it opens down?
Yes.
Okay. Just write myself some little notes. So, is that exactly what this parabola looks like? No, I just want right? But I know it opens up, so I'm just getting the general idea of how this opens, right? And then I need to draw and label my axis of symmetry. Where does it go? X equals 2. So it goes right through the what? What'd you say? Wait, does my axis of symmetry always go through my vertex? Oh, excellent. There's my axis of symmetry. How do I label it? X equals 2. Are there any questions on what I want on your homework? When the directions say graph, identify the vertex, and axis of symmetry, this is exactly what I want. I want graph paper with the exact parabolas. We have our calculator for that, and we can use a table if we need to. That's not where we are for today. That's not our focus. Okay? I want to make sure you know if it opens up or down. I want you to know how to find the vertex. I want you to know how to find the axis of symmetry. You okay with that? Okay. In a similar section where the directions are still the same, graph, identify the vertex, and axis of symmetry, there might be problems that look like this. So I want to identify the vertex. And axis of symmetry. And then I eventually want a graph, right? But I really need to find my vertex and axis of symmetry first, don't I? Okay. Well, this is in standard form, right? So finding the x coordinate of my vertex, I need negative b over 2a. Negative b over 2a. Well, what's negative b? 8, right? It's the opposite of b. Over 2 times negative 2. Well, what is 8 divided by negative 4? Negative 2. So the x coordinate of my vertex is negative 2. How am I going to find the y coordinate of my vertex? What does this mean? What does this mean? Find the value of the function at negative b over 2a. What's the layman terms for that? How about plug it in? Right? I know an x. Can't I plug this in to find the value of the function? Okay. So negative 2 times negative 2 squared minus 8 times negative 2 plus 1. What's negative 2 squared? Negative 2 times negative 2. 4 times negative 2. Negative 8 plus 16 plus 1. What's negative 8 plus 16? Negative 8 plus 1. Oh, it's just positive 8. Oh, that's what you're saying. Okay, negative 8 plus 16 is 8. 8 plus 1 is 9. So that is the y coordinate of my vertex. So what is my axis of symmetry? X equals negative 2. Now for my graph. I got to think ahead about this a little bit, right? I want to plan ahead. If I'm thinking like if I just use this graph, I would go negative 2, positive 9. So when I draw my graph, I really need to give myself some room over there, right? Looks a little different axis than this one over here, because I got to go negative 2 and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2, 9. What direction does this parabola open?
Down.
How do you know?
Because A is negative.
A is negative, so it opens down. Where's my axis of symmetry? Right through the vertex, crossing the x-axis. And it's called what? X equals negative 2. Okay, so far? Any questions on being able to find vertex and axis of symmetry, whether it's in vertex form or standard form? Okay, so there's one more section on your homework, when it gives you an equation or a function like this, but this time it asks for two different things. It asks for the minimum or the maximum, and it wants you to tell it which one it is, and then it asks for the domain and the range. So is it asking for completely different things here? So it doesn't want to know the vertex at all? It doesn't?
Well, vertex could be the minimum and maximum.
In fact, isn't it? If I have a parabola that's opening up like this when my a value is positive, it's the minimum. So if my a value is positive and it opens up, I'm going to be finding a minimum. If I have a parabola like this that's opening down because a is negative, this point is going to be the But either way, both of those points are still the what? It's the vertex. So I'm still finding the vertex. They're just calling it something different. They just want you to know it means the same thing. Okay? So first of all, tell me, in looking at this equation, am I finding a minimum or a maximum? How do you know it's a minimum? A is positive, so it's opening up, so I'm finding a minimum. Okay? So I'm still having to use negative b over 2a though, right? Negative b over 2a. So in this case, negative b would be negative 2 over 2 times 1. What is negative 2 divided by 2? Negative 1. So the x-coordinate of my vertex, or my minimum, is negative 1. How do I find the y-coordinate again? Plug it in. Can I show you a couple different ways to do that? That's maybe sometimes faster. Not always, but maybe sometimes it is. Okay? First of all, I could open a calculator page, and I could say x is negative 1, right? So I'm going to store negative 1 as x. And then I'm going to put in the equation. X squared plus 2x minus 1. And get negative 2. Or I could instead open a graph page, and I could put in x squared plus 2x minus 1, and look at my table, Control T, where x is negative 1. And it says negative 2. Or I could just say negative 1 squared is 1. 2 times negative 1 is negative 2. So 1 minus 2 is negative 1. Minus 1 is negative 2. There's just 3 ways right there, and that's not even all of them. Okay? I could make my table go away, and I could say menu, analyze my graph, and it finds the minimum for me. Left side, put it on, the lower bound is on the left side of that point. Upper bound is on the right side of that point. Look, negative 1, 2. Negative 1, negative 2. Do you see that? Is everybody okay with that? That's just 3 different ways right there. To me, on this particular problem, it was just faster to plug this in. But it's not going to be all that way all the time, so I wanted you to see different ways that were possible. Okay? What is my domain for this problem? Okay, well, here's the deal. You guys know you're not wrong. Okay? You are not wrong. But you guys know that I'm a visual person, right? I like to see it. Now I've got, whoa, careful. I've got this graph right here I can look at. And I'm going to go ahead and sketch that real quick on my paper. Negative 1, negative 2. So that I have it. Okay? There's my vertex. Now, looking at this, or even in the one in my calculator, I can tell, and he already knew that the domain was all real numbers, right? That's an inequality notation. What is it? What is it in interval notation? Negative infinity, positive infinity. Very good. Okay. What about my range?
It is
Range is down to up, right? So how, y is greater than or equal to -2. How do I write it in inequality notation?
this is somewhere wait.
-2 to infinity?
Here it is.
What goes where? Is this it? That's right? Oh, I need a bracket right here. Okay. Guys, if I look at the range, does anything in the vertex help me?
Yes.
Look how far down it goes. It tells me. All I have to know is if this is opening up or down, so I know if it's -2 to infinity or if it's -infinity to -2, right? That's why I like to draw the graph, so I know it's opening up or down. It's not required. It doesn't even ask you to draw the graph. It says find the minimum and maximum and domain and range. That's what it says. But if you want to draw a graph to help you out, that's fine. If you don't want to, that's also fine. Okay? Any questions about this? Could you find the vertex and axis of symmetry in vertex form or standard form? Could you find the minimum, maximum, and the domain and range in any form? Okay. Any other questions?